about that.
Remember, class, we have a big math exam tomorrow. I'm not going to waste any more of your time, so let's start reviewing.
Hello there. You may be wondering why I'm here, and I have discovered that you have been having trouble with the 5 triangle proofs of geometry. So tonight you will have 5 math lessons about the 5 triangle proofs of geometry.
What?
Angle QTR is congruent to angle SRT, and our other given is angle TRQ is congruent to angle RTS. So what we want to do first is go ahead and write down all the givens. So angle QTR is congruent to angle SRT because of course it's given. And our second given, which is angle TRQ, is congruent to angle RTS, and this is given too. So we can go ahead and in the picture incorporate these two by showing that they're congruent. So TRQ is congruent to angle RTS. And then for our other one, angle QTR is congruent to angle SRT. So next we want to look at our line segment RT, which is of course congruent to itself. So RT is congruent to RT because it's reflexive. So we have an angle, a side, and an angle. So our triangle RST is congruent to triangle TQR because of angle, side, angle, using lines 1, 2, and 3 from above. Alright, so now we're on proof type 2. So we have our given, which is line segment PQ by 6, as angle SPT, and line segment SP is congruent to line segment TP. So what we want to do is go ahead and write all this down. So our first one is line segment PQ bisects angle SPT because of course it's given. And for our second line, we want line segment SP is congruent to line segment TP because of course they're congruence. And for line 3, we want to have PQ line segment is congruent to line segment PQ because of course it's the same line. And This is because of the reflexive property. And then for our fourth line, we want angle SPQ is congruent to angle TPQ because of the angle bisect. So let's go ahead and put all this down on our picture. So SP is congruent to TP, and PQ bisects SPT. So now we have a side and an angle and a side. So for our fifth line, we can now prove that triangle SPQ is congruent to triangle TPQ because of side, angle, side, using the rules 4, 2, and 3.
This is proof type 3, and we have two givens. We have line segment FH is parallel to LK, and line segment GF is congruent to GL. And we are trying to prove triangle FGH is congruent to triangle LGK. So what we first do is we write down our givens. So FH is parallel to LK, and the reason is because it's given. And then line segment GF is congruent to line segment GL. So what we can do when we look at the picture, we can do two things. The first thing that we can figure out is vertical angles. So angle HGF is congruent to angle KGL, and that is because of vertical angles. The next thing that we can do by looking at the picture, since it says in our given that K and L are parallel to F and H, we can do our interior alternate angles. So angle FHG is congruent to angle LKG. And this is because if lines are parallel, alternate interior angles are congruent. And then what we can do, we can write this in on the picture. So angle HGF is congruent to angle LGK, so we wrote that in, and then that angle H is congruent to angle K. And then in our givens it said that GF is congruent to GL. So then what we have is triangle FGH is congruent to triangle LGK because of angle, angle, side, and we use lines 2, 3, and 4. This is proof type 4, and we have two givens. UR is parallel to ST, and angle R and angle T are right angles. So the first thing that we do, we put those into the givens, which I already have. We put it into the statement, and the reason is because they're given. So then after that, because RT, angle R and angle T are right angles, we can say that angle R is congruent to angle T, because all right angles are congruent. So the next thing that we can look at from our givens is it's saying that UR is parallel to ST, and we have a line cutting through. So when we have those, we can do alternate interior angles. So angle RUS is congruent to angle TUS by if lines are parallel, alternate interior angles are congruent. And the next thing that we can see in this picture is that US is congruent to US. So now that we have that, we're trying to prove that angle RSU is congruent to TUS. So how we can do that is by saying that these two triangles are congruent to themselves. So how we can do that is by putting triangle RUS is congruent to triangle TSU by angle, side, and we use lines 2, 3, and 4. And when we have triangles congruent to triangles, we have this property called CPCTC, and which we're going to use. So angle RSU is congruent to angle TUS. And we can do that by CPCTC. So we're on proof type 5, and we have 3 givens. AB is perpendicular to AD. DE is perpendicular to AD. And BC is congruent to EC. And we put all 3 in our statements, and the reason why is given. So what we can first do is put BC is congruent to EC. So we can mark that on our picture right now. So next thing that we'll do is we'll do alternate interior angles, because A is congruent to angle D. So we can put that in our picture, and then we can write that down. Angle A is congruent to angle D, and that is because alternate interior